So, good morning, students. Welcome to our LIC class. And today we are going to discuss the pinout diagram of 555 timer IC. And along with that, we are going to see the functional block diagram with one of the application. Now, whenever we talk of timer IC, why do we call it timer IC? And why the name 555 is there? Along with that, why do we use it? And what is the inside your, because whenever you people are going to study about this, you will find the inside diagram of this IC very nice, because as such it is your combination of analog as well as digital circuits inside the IC. Okay, so let's see it, and let's look at the pinout diagram. So we are going to see the pinout diagram of this IC. It is an 8-pin IC. It is an 8-pin IC in DIP, dual in line package. Okay. Here a notch would be there. Pin number 1, pin number 2, pin number 3, pin number 4, pin number 5, pin number 6, pin number 7, and pin number 8. Now, what are the basic name of these all pins are? You have to remember that the pin number 1 is your ground. Pin number 2 is your trigger. Now, no need to worry about this. We are also going to see how actually these pin configurations are given and how they are connected inside. Along with that, at the start of lecture, I had already told you that this IC is very beautiful from inside. That is, it is having both the these are the names of our pin. So how you have to remember that pin 1 is ground, pin 2 is your trigger, pin 3 is your output, pin 4 is your reset, pin 5 is your control voltage, pin 6 is your threshold, pin 7 is your discharge, and pin 8 is your supply. Now, this is the basic diagram that we have to remember about this IC. Okay. I am going to just name it like this. Okay. Now, why the name 555 is there? Along with that, how we are going to look upon the various pins and how they work and what is the inside of this. So, let's look at the functional block schematic. Okay. Now I will go in a maneuver in which you are going to see section wise. Now the name is 555. That means basically 5 kilo ohms 3 resistors are being connected. 1, 2, 3, and simply ground. Okay. Now just name them. Pin number 8, your VCC. Pin number 1, the ground. Okay. Now what I have to do? 5 kilo ohms, 5 kilo ohms, 5 kilo ohms. So basically 2 pins have been covered in this section. The input side, 3 resistors are there, and each resistor's value is your 5 kilo. And by these 3 5, you get the name 555 IC. Now when we come to the forward side, the second section, it is your comparator part. The comparator part. 2 comparators are there. How they are being connected? Let's look. Now as we know, we are having compares, as I told you in the previous classes while we were studying the comparator, op-amp as an comparator. So you just have to simply remember them. Okay. Now the 2 comparators are there. This would be your pin number 6. This would be your pin number 2. Pin number 2 is your trigger. Pin number 6 is your threshold. Okay, pin number 6 is your threshold. Now, the two terminals that we are naming as pin number 6 threshold, pin number 2 trigger. But what about the two terminals that are being connected to the 5 kilo ohm your resistors? Here, the three resistors are acting as voltage divider network. The three resistors are acting as voltage divider network. So in this voltage divider network, actually what happens, whenever we look upon the inverting terminal, okay, the inverting terminal of the first comparator, it is your pin number 5, we also name as control voltage. We also name it as control voltage. It is your pin number 5. Here the potential is 2 by 3 VCC. Okay. Here again the positive terminal of the second comparator, positive terminal, I will name them 1 and 2. The positive terminal of the second comparator is connected to again the voltage divider rule, and it is given by 1 by 3 VCC. 1 by 3 VCC. Now actually how your comparator works, that we will see in the next diagram. Now output of these two comparators, comparator 1 and comparator 2, is being provided to a digital circuit. You people had gone through this. It is your RS flip flop. It is your RS flip flop. S, R, Q and Q bar. Q bar is actually your output, the pin number 3. Okay. Asynchronous input along with this is being given by pin number 4. We name it as reset. We name it as reset. So look how many pins we had checked. Pin number 4 reset, pin number 2 is trigger, pin number 6 is threshold, pin number 5 is your control voltage, pin number 8 is your VCC, pin number 1 is your ground. Also let's check 1, 2, 3, 4, 5 and 6 we had checked. Okay. Now output from this Q goes to the discharge register. Output from this Q goes to the discharge register. Pin number 7. Pin number 7. Okay. So this is your basic whole configuration of the 555 timer internal block schematic, how it works. Now actually let's look, or let's divide it into sections. So we can divide into 4 sections. This would be your one section. Okay, this would be your second section. Okay, this would be your third section. So we can divide this into okay. The fourth one is the output section, third one is the digital section, the second one is your comparator section, and the first one is your the voltage divider network. The 3 5 kilo ohm resistors are being connected. Now let's look actually how it works. Simply while it's working, I take again the 3 resistances. Okay, 1 resistance, 2 resistance and 3 resistance. Now I just draw the 2 comparators here. Comparator 1, comparator 2. The plus input, the minus input, the plus input, the minus input. Okay. Now, what was the diagram? Let's recall it. Going into the latch, or your basically flip flop. Okay. Now, the minus pin was being connected to the pin number 5, control voltage. The plus pin was connected threshold. So at pin number 5, the voltage always is 2 by 3 VCC. At pin number 5, the voltage always is at pin number. So we know voltage divider rule, V into the voltage that is being calculated upon the total voltage, suppose R1 plus R2 plus R3 into the R1. Okay, so it will give you all three resistances are same. All three resistances are same. So suppose I have supplied 9 voltage at the VCC. Here I have supplied 9 voltage at the VCC. So what would be the voltage at pin number 5? It would be 9 into these resistances, 2 resistances upon 5 into 3. 5 into 3. Okay. So in this maneuver, we will get, okay. So let's look at it. Now, this is your pin number 2. Okay. And this is your pin number 3. Now, this is being connected, the positive terminal 1 by 3 VCC. 1 by 3 VCC. This is your trigger. Okay. This is control voltage, and this is your threshold. Now, actually, we are going to look how these things work. In a rough maneuver. Suppose this is your comparator 1. Plus, minus, and this is output. Now, this is your threshold voltage, the upper pin. Okay. So, and the negative terminal is being connected to 2 by 3 VCC. Now, whenever the threshold voltage exceeds 2 by 3 VCC, it is going to give you 1. And whenever the threshold voltage, pin number 6, goes below 2 by 3 VCC, it is going to give you 0. That means terminal pin 6 is greater than 5, you are going to get a 1 at the output. If pin number 6 is less than 5, you are going to get a 0. Okay, these are voltages. Let's remember this. Same maneuver in the case of second comparator. This is your comparator 1. Same maneuver when I talk of comparator 2, let's look. Your positive terminal of the comparator is connected to 1 by 3 VCC. And this is your trigger input. Okay. So pin number 2. Now, as soon as the voltage at the positive terminal exceeds the pin number 2, goes below 1 by 3 VCC, the voltage at pin number 2 is below 1 by 3 VCC, comparator will give 0. And when voltage at positive terminal is above or equal to 1 by 3 VCC, the comparator 2 is going to give you a 1. So you have to remember this. Okay. Now these 1 and 0s are being fed to your digital section. These 1s and 2s are being fed to your digital section. Okay. So how does it actually works? Okay. All this pin configuration, this discharge, and how we can use our this 555 IC. We had seen the internal diagram. Now some of the features of 555 IC we are going to discuss, and then I am going to show you one of the application of the your 555 IC. So features of IC 555. Let's make it somewhat fast. Okay. So this is a timer device actually. This is a timer device. Timer device can be used to generate oscillations. Can be used to generate oscillations. Can be used to generate oscillations. Now in this you can take a stable mode, monostable mode, bistable mode. So this is one of the application. Along with that, your working range, you can give VCC from some 4.5 volts, to 15 volts. Okay, 15 volts. You can use the output of IC. Both in sync and source mode. Okay, very important feature regarding this. Okay. So guys, here I had plotted one of the application of your timer IC working as an astable multivibrator. Okay, astable multivibrator, and in this the formula for the frequency output is being given by, or the time is being given by, T is equal to 0.693 into R1 plus 2R2 into C. Okay, so here we have chosen two values, your R1 and R2. Now in this, the simply your monostable, this astable multivibrator works as a pulse generator. Let's look: on, off, on, off, on, off. Okay, this would be the output. Roundabout approx VCC would be the output voltage. Along with that, when you find during the positive half cycle, your capacitor charges, here it discharges, here it charges, here it discharges. Okay, here it again charges and discharges. So this is what this is your capacitor's waveform at pin number 2. Capacitor waveform at pin number 2, and this is at pin number 3. So you have to remember this, and the time period would be given by this formula. So learn this, go through this, perform this practical in the lab also, so that you can learn about timer IC. Thanks a lot. Thanks folks for listening to the video. Bye.